003. Perform diagnostic tasks on electronic brake-controlled systems. Diagnosis overview. The diagnosis of ABS, TCS, and ESC systems starts with a thorough understanding of the particular type of system you are working on. Refer to the service information to familiarize yourself with the manufacturer's description and operation of the system. Also check for any DTCs related to the customer concern. In cases where the system warning lamp is illuminated, access the diagnostic trouble codes, DTCs, with a compatible scan tool or code retrieval key. DTCs can be diagnosed following the steps laid out in the service information pertaining to the specific DTCs indicated. In cases where the system warning lamp is not illuminated, indicating there are no faults stored in memory, you can sometimes follow the symptom charts listed in the service information. Just remember that the EBCM makes decisions based on the sensor information and software programming. Those decisions are then sent as output signals to the HCU unit, the vehicle's PCM, and other controlled devices. The controlled devices then need to carry out the commands. So knowing that information, along with the verified customer concern, and the service information, you will be able to diagnose the cause of EBC faults. Tools A, B, C. Figure 1. Tools used to diagnose electronic brake systems. A digital storage oscilloscope or diagnostic scan tool. B. A handheld diagnostic oscilloscope. C. A digital voltometer. The tools used to diagnose and repair ABS, TCS, and ESC systems include these, shown in Figure 1, ABS code retrieval key, a stamped sheet metal key used to access the ABS blink codes on earlier GM vehicles. Scan tool. Handheld electronic tool used for accessing ABS codes and live data from the EBCM. Some have bidirectional abilities used to command certain outputs, such as activating a solenoid during a diagnostic routine or when bleeding the brakes. They are also used to clear codes after repairs are completed. Oscilloscope. Handheld electronic tool used to display electrical waveforms relative to voltage signals over divisions of time, such as wheel speed sensor patterns. DMM. Handheld meter used to measure volts, ohms, and amps in electrical circuits. ABS proportioning valve depressor. Device that depresses the proportioning valve on some ABS systems while bleeding the brakes. ABS pressure tester. Device that allows the technician to test accumulator and HCU pressure issues. Diagnosing all EBC systems. If the yellow warning lamp is illuminated, indicating there is a fault in the system, retrieve any DTCs following the procedure listed in the service information. If the yellow warning lamp is not illuminated, and the brakes are not functioning properly on a vehicle with an EBC system, suspect a problem that is not monitored by the EBCM. This could be from a fault in the base brake system, such as warped rotors, contaminated friction lining, or a seized caliper piston. Diagnose these problems like you would on a non-EBC system. It could also be a problem in the hydraulic system, including the HCU, such as a dump valve that is stuck partially open or an isolation valve that is stuck closed. Even systems that are monitored by the EBCM can cause operating concerns without the yellow warning lamp being illuminated. An example would be a wheel speed sensor that does not have the correct air gap. Using the manufacturer's diagnostic symptom charts and system diagrams and having a good understanding of brake, hydraulic, and system theory will help you diagnose the cause of the concern. Most EBC-related faults set DTCs and store them in memory. A good starting point for diagnosis is retrieving any stored DTCs with a scan tool or code retrieval key. The service information provides a testing procedure for each of the fault codes. Following the steps listed and using an understanding of brakes, electricity, and the circuit being tested will help lead you to the cause of the fault. To diagnose EBC system electronic control, S, and components by retrieving DTCs, first connect the scan tool to the data link connector. Navigate to the code retrieval screen and record any DTCs. Research the TSBs and diagnostic procedure for the stored DTCs in the service information. Follow the diagnostic chart to diagnose the cause of the fault. Once the fault has been corrected, clear the diagnostic code, and verify that it does not reset. This may involve a test drive. Diagnosing wheel speed sensors and tone wheels. Wheel speed sensors are a high probability cause of illuminated EBC warning lamps and stored DTCs, because they are usually mounted where they are exposed to the elements and in harm's way. Watching their speeds during a test drive allows you to see if they are reading the same speed or not. If not, then check for mismatched or improperly inflated tires. If the tires are not the cause, then testing the wheel cylinders for electrical faults is a common step in EBC diagnosis. Measuring the output signal with digital storage oscilloscope, DSO, or a graphing multimeter, GMM, and comparing it to known good signals is the most conclusive method of testing the sensors. Variable reluctance type sensors, passive, create an analog AC sine wave. Magnetoresistive type sensors, active, and Hall effect sensors, active, create a digital square wave signal. The sensor electrical circuits can be tested with a DMM for opens, shorts, high resistance, and grounds. Technician tip. When checking variable reluctance sensors, it is important to use a true RMS meter because the sensor outputs an alternating current, AC, signal. A true RMS meter is designed to accurately represent this signal. Non-true RMS meters can only accurately represent clean AC signals, not faulty ones like true RMS meters can. If the meter is a true RMS meter, it typically is labeled as such on its face. The tone wheel can usually be visually inspected for any faults, such as broken or damaged teeth. Just make sure you inspect the teeth all the way around the tone wheel, not just in one section. Also verify the air gap is within specifications. To test and diagnose EBC system speed sensors, digital and analog, tone wheel, and circuits, first read any diagnostic codes with a scan tool or other code retrieval method. Using the DTCs, determine which wheel speed sensor or sensor circuit is at fault. Research the service information to determine what type of speed sensors the vehicle is equipped with in the specified testing procedure. To test variable reluctance sensors, follow the steps in Skill Drill 1. Skill Drill 1. Testing variable reluctance sensors. 1. Disconnect the suspect's sensor, measure its resistance, and compare the reading to the specifications. If the resistance does not meet the manufacturer's specifications, replace the sensor. 2. If it is within specifications, test the two-wire circuit back to the EBCM for opens, shorts, high resistance, and grounds. Repair as necessary. 3. If the circuit is good, reconnect the speed sensor connector, and attach a GMM or DSO to one of the sensor wires. 4. Spin the tone wheel, and observe the pattern. It should be a clean AC analog pattern of sufficient amplitude, voltage. 5. If the pattern is not correct, inspect the tone wheel for damage, and replace as necessary. 6. If the tone wheel is good, replace the wheel speed sensor. If the pattern looks okay, you may have to compare it to the other wheel speed sensor signals while driving the vehicle. After repair, clear the diagnostic codes, if directed by the service information. To test magnetoresistive sensors, follow the steps in Skill Drill 2. Skill Drill 2. Testing magnetoresistive sensors. 1. Make sure the ignition switch is in the run position, and measure the available voltage at the suspect's sensor. Also check the ground for voltage drop. 2. If the voltage does not meet the manufacturer's specifications, test the circuit for opens, shorts, high resistance, or grounds. Repair as necessary. 3. If the voltage to the sensor is within the manufacturer's specifications, connect a GMM or DSO to the signal wire. 4. With the key in the run position, spin the tone wheel, and observe the pattern. It should be a clean digital square wave signal of the appropriate height and shape. 5. If the pattern is not correct, inspect the tone wheel for damage, and replace as necessary. If the tone wheel is good, replace the wheel speed sensor. 6. After repair, clear the codes if directed by the service information. Applied Science. S85. Problem solving. The technician can use computers, scan tools, and onboard data to diagnose problems. Vehicles presenting with ABS warning lights illuminated are now almost an everyday occurrence in most workshops. The first step in the diagnostic process is to read the DTCs stored on the ABS module. The most common cause of ABS malfunctions is faults in wheel speed sensor circuits. Common causes of wheel speed sensor circuit faults include corroded or poorly tensioned connectors, mismatched tire rolling diameters, and physical sensor failures. Possibly the most effective way to diagnose wheel speed sensor circuit faults is to utilize the live data function of your scan tool. Start in the shop, looking at the speed readings, and making sure they are all equal before you even test drive the car. An inconsistency indicates a fault. During the road test, look at the graphed data outputs from all of the sensors. They should all look consistent. A graph that differs from the others indicates a faulty circuit. Once you have identified the affected circuit, the next step is to test at the sensor with a graphing multimeter or an oscilloscope. Diagnosing braking concerns caused by vehicle modifications. The EBC systems are engineered so that all of the parts and the programming work together for the purpose of assisting the driver in maintaining control of the vehicle. If any of the original components get replaced with non-standard parts, the EBC systems will not perform as designed, putting the occupants at risk. Examples of this could be as simple as installing a smaller spare tire on the vehicle due to the original, correctly sized, tire going flat. The smaller tire turns at a faster rotation than the original tire, confusing the EBC system. Consequently, the yellow warning lamp illuminates, and the EBC system is disabled. In the same way, installing larger tires with a greater circumference will cause the wheel speed sensors to report a slower wheel speed than the vehicle is actually traveling. Because the EBCM is not calibrated to match this parameter, the system cannot respond appropriately, and again a DTC will be reported, and the EBC system will shut down. Changing curb height causes the vehicle's center of gravity to change. Taller vehicles tend to transfer weight more easily. In the case of braking, the weight is transferred to the front wheels, unloading the rear wheels. This makes the rear wheels more prone to lock up. In the case of cornering, the weight transfers to the outside wheels, unloading the inside wheels. This makes the vehicle more susceptible to rollover. In both of these cases, the EBCM is not programmed to take into account the non-stock height of the vehicle. Therefore, the EBCM would not be able to properly anticipate the vehicle's actions in these scenarios. Changing final drive ratios causes the same situation as changing tire size. The vehicle wheel speed sensors will report a different speed than the vehicle speed sensor, and the EBCM will set a code and disable the system. Also, mismatched final drive ratios on four-wheel drive vehicles can affect the EBC systems, as they can cause the wheels to rotate at slightly different speeds, front to rear. In some cases, the EBCM can be reprogrammed with the new vehicle information, or an EBCM that does match the new parameters of the vehicle may be available for installation. In any case, technicians need to be aware of how these factors affect the EBC systems. They also need to know how to verify that the components match the information programmed into the EBCM.